Swayam Prabha. Digital India. Educated India.
So when you talk of cybersecurity, there are some industry standards, guidelines, best practices, procedures, right? So NIST is one of the organization, globally, they provide these frameworks. It's called National Institute of Standards and Technologies. They give you a lot of frameworks. Using that, when you adopt these standards, it will help you to minimize the risks, right? So how does the cybersecurity framework of NIST work is? The first step is to identify what are the assets that you have. It could be servers, applications, employees, everything. Understand the business environment. What is the governance requirement? What is the, like I said, SOX control, HIPAA, all those components. What is it that from the governance perspective you need to do that? What are the risks associated with these assets, right? It could be natural risks, right? Earthquake. Is my data center of my organization is located in the location which is prone to earthquakes, right? Or fire, or any other calamities. So you do all this risk assessment. What are the threats that my applications and servers could encounter? And then what is my risk management strategy? So the first step of NIST cybersecurity is to identify these things. The second one is to, how do I protect? Okay, I have my systems, I have understood what are the risks of all these things. How should my how should I have my access control in place? How far I control awareness and training? How often do I provide these things? What are the data security requirements? How do I do that? How do I protect my systems? Information policies, procedures, and technologies that I use. Okay. The other one is, like I said, detect. It's not about doing the assessment, put some protective measures. It's about detecting. It is a constant process. Like I said, it's a continuous process. So you have to find out the anomalies. What are the events? Like I said, security incident event monitoring. So this is a it's more of a hygiene. We talked about cyber hygiene, right? And what are the detection process that I have? Then how do I respond? If there is an incident happening, if there is a ransomware attack, what will be my response plan? Okay, will I restore my systems from my backup systems? Will I point the application to my other systems in other region? So this is more about how do I respond to any of these things? How do I communicate? Okay, now we talked about compliances and regulations, right? It is even in India, the data protection plan says if there is an incident, you have to publish it within 24 hours. It used to be 72 hours. You have to publish. There is a data breach that has happened in our organization. We are taking the following measures to mitigate the risk. What is the impact to the end users? What is it for the organization? Everything. So communications is one of the key steps in this response process. Then analyze, mitigate, and how do we improve my system? Then how do I recover it? No. It is a universal. See, this is a guideline. When they say NIST gives this framework, by adopting this framework, then you, for each of these things, you may have a method. It's not that you have to follow only one way of doing these things. For example, asset management. NIST is a global organization. Okay. Exclusive for? No. It's a framework regarding cyber security. How do you secure systems? Okay. What are the steps that you should follow? There are so many documents available in the NIST. Okay. So it's a guideline. These are the stages through which you ensure that you do a risk assessment. You protect. How do you protect your systems? Is like I said, not every organization will have enough money to spend, right? But still, how do you do that? You have to document it. Okay, if somebody is an NGO, they may not have enough money. They may be okay with certain risks, but you have to document these are the risks that we expected. These are the control measures that we are putting in place, and we are okay with that risk, right? Like I said, if a system is down for 2 hours, what is my loss? Am I okay with that loss? This for the organization to decide. But if there is a legal requirement, then you are bound to adhere to the legal guidelines. Okay, if you are a business entity, banking, you are managing millions of customers' data. You cannot say that I cannot restore my system in the next 1 hour. HDFC Bank recently got, and everybody was publishing that system is slow, system is no, I am getting false messages from HDFC Bank, all those stuff, right? So the frameworks are just to ensure they give you some guidelines. If you follow these practices, then you can minimize your risk. They are not mandatory, but it's a standard, right? If you say that, okay, how do you walk on the road? Hey, you walk on the pavement. It's a guideline. But if you walk on the road, you are supposed to know what are the risks, right? And this is a key concept, security by design. We talked of when you develop an application, how do you develop it, right? With the security in mindset. So security by design is one of, no, we talked of least privilege. So as you develop the system, hey, who is going to have access to my system? Am I allowing only those people who are required to access the system, right? Defense in depth. We talked of least privilege. We talked of zero trust security, I said, right? So defense in depth is like, even if the first stage I get compromised, will my next stage detect that? Will the third stage detect that risk? For example, network access control is the first step. Firewall itself should detect. But if the firewall due to some misconfiguration it has allowed, then I am reaching my server. In the server, am I restricting it? Right? Who has the administrator privilege? If the third party tries to get that administrator privilege, they can transfer it. That's called lateral movement. If I get access to one server in my network, I can easily access all the other servers in the network. So defense in depth is then, okay, I am getting access to my server. There is an application. Do I have authorization in place to access that application? So this is called defense in depth. Every stage you improve. So even if one system fails, the other system should take care of it. Default secure settings. Okay, there is something called fail secure and fail insecure. For example, if you are using a Windows laptop, you see a blue screen depth, right? Depth of blue screen, right? It crashes and it puts some garbage on your screen, 00, hexadecimal, all the stuff, right? It is it's called fail secure, meaning that your system is protected. There is some incident has happened which has caused the system to fail, meaning that fail recovery is that, okay, there is a known patch, okay, or there is a system fault itself, and the system will recover and then it will come to a login prompt. Okay, so you have to understand between, is my system fail secure rather than fail insecure. If there is a vulnerability in the firewall, okay, and if the firewall has failed, okay, for example, it should remain fail state sometimes, because it should, if there is a failure and the third parties get access to the system, which by default should be denied, right? So you have to understand, when I design my system, should it be fail open or fail secure? So it should always be like, if the firewall fails, the secondary firewall should take over. So that is called fail open. If one firewall fails, the other should take over. But if there is a problem, if there is an incident, then the second firewall should not take over. It has to be fail secure. It has to be denied. Then you will analyze what is the incident, why it failed. Then you open the system manually. And audit trails. We talked of how often do we do auditing? Every time. If every transaction, every access should be logged and monitored. This is what defense in depth. For example, right? So you have, say both are same. So when we talked about in brief in the earlier, right? Cybersecurity is all about so many things. So you have a perimeter security or a physical security. You have a data center, Google data center, right? It's a big campus. So you have compound walls. You have all those stuff, electric fences, everything. So what is my perimeter security? Then inside that you have a network. right? Corporate network, we have data centers, all the servers, storage, everything is there, firewalls, everything is there. Endpoint security is more about end user devices, right? So how am I protecting my laptops? Is every system is patched with the Windows, latest Windows patch, or whatever, the Linux, all those stuff. Within that you have an application. An application resides in your server, or it could be in your laptop also. So what are my application security controls? And finally below it you have the data, which is the crown jewel. All you do is to just to safeguard this data. So to safeguard this data, every layer, right? So that's where it's called in-depth. If there is a problem there is a breach in this layer, the next layer should protect, or the next layer, next layer, next layer. So this is called the defense in-depth principle. End of the day is to protect the end user's data. And you see this in this side, you have a policy management. So policies are more of a guidelines, corporate level things. Hey, this is what our standard says. For example, interns will have access to only these systems. If you are in the database team, within the database team you have so many databases, which users will have access to financial database, which users will have access to, these are high level things which are approved by the top management or board of directors. This monitoring and response, it's again a real time activity, real time monitoring, real time response, right? All those. So this is one of the things you need to understand. Defense in depth is very, very important. And sorry about it again, because it cannot be made more visible. So defense in depth across layers, for example, operations, technology, people, right? For example, defense in depth, for example, people, you take, right? If there is a flood, my data center is flooded. So which people will have access remotely to access the data center, right? Or I have a business continuity, as part of business continuity plan, I have a disaster site. If there is a disaster in my primary site, how do I restore from my remote site? Banking systems are mandated to have business continuity plan, disaster recovery sites across. If across regions, you cannot, for example, India have operations. Probably a disaster recovery system should be in Singapore or somewhere else. Okay, so defense in depth across layers. Okay, you have wireless security. Everything, it covers everything, systems and network, data security, physical security, for everything, every aspect. How do you ensure that there is a redundancy in plan? How do you mitigate those risks? No, these things will coexist. See, we will come to that. I will tell what is the need for cloud, why we went in for cloud. We will cover that. On premises will exist. See, like I said, it's all about how much you have in, or how much you can eat. It's based on how much you have, or how much you can absorb, right? So every organization, you have startups, you have established organizations, you have large organizations who spend billions of dollars in R&D itself. But for some organizations, it's all about existence. They cannot pay their employee salaries also. So it's all about, that's where cloud came into picture. Okay, we will see that, we will go into that. Alongside, we will see some best practices. Okay, ma'am was also asking about what is the best practice when you say talk about secure coding or development, management, operations. What are some of these things, right? These are some of the critical things: error handling and logging. When you develop an application, how do you publish your errors? What should be visible internally for the application? What should be visible for the end user? For example, if there is a wrong user ID entered or a wrong password entered, what do you show to the user? Incorrect password. But within your system, how do you capture that and interpret it? Error code 001, more than 3 attempts, right? Incorrect password. So error handling and logging, both are important, right? So if there is a retry of more than 3 times, that should be logged. Then only you can identify whether it was a genuine user who forgot his password, or some malicious user trying to enter into the system. We talked of data protection, encryption, right? Hashing, secure protocols, all those stuff. So how do we ensure that that crown jewel data is getting protected? Defense in depth. So this is one of the best practice. Configuration and operations, we talked of open ports, unnecessary ports being open, right? Access controls, not everybody having the same things. So when you configure the system, how do you configure all these things? Okay, and how do you, in the operations world, how do you do that? Authentication, we talked of multi-user, multi-factor authentication, all those stuff, right? Whether it is the genuine user, biometrics, all those stuff. Session management, we said, no, you don't terminate your current session, you're bound to encounter problems. So how will you manage your sessions using cookies, all those stuff, right? Input and output handling, we said, right? Input validation. Okay, if somebody is entering a wrong character, or instead of legitimate number of characters, any other special characters in your scripts, in your SQL injection we talked about. And finally about access control. So these are some of the best practices you should always follow, okay, at all stages, whether you are in development, whether you are in operations, whether you are in the network security, cloud, everywhere. So we may not have enough time to go through every point. I have probably, I think in NPTEL also you can have access to these things. So go through. Again, this is more of elaborating on the previous points, right? So it talks about in depth about every other point. Okay. So error handling and logging. What are the best practices within the error handling and logging? For example, display generic error message. See, error messages should not reveal details about the internal state of the application. You should not throw some, like I was talking about the Windows throwing blue screen, right? Hexadecimal values and all that, because it reveals information about what is the current state of your system. It should not. So it should be generic SMJ. For example, unable to provide access to the system. Why it was unable to provide, you may not want to reveal to the end user, right? Incorrect password, wrong password entered. But you may want to understand what your application has thrown out as an error internally, and then have generic within your application. If this is the error, what should be the problem? Okay. So unhandled exceptions, you have to handle all those exceptions. Okay. For example, buffer overflow. You have designed your application to accept, for example, if it is an 8 character, probably 16 bytes or something like that. If there is a memory leakage and it consumes all the things, right? Buffer overflow is one of those exceptions. How do you handle all those exceptions? All authentication, privilege changes, administrative accesses. For example, any administrative access on the application should be logged, meaning that if I am a normal user, right, I try to change the password of somebody else, can the system allow that? Only the administrator should be able to reset my password, right? Or if it is self user can change the password, only for themselves they can do that. This is called privilege escalation, right? That's what the hackers or any other malware, malicious people will try to do. They will first try to get access into your system, then they will try to do some privilege escalation. Hey, can I become a root user of the system? Okay, if the root user password is not hard enough, then they will know what is by default. Even the routers or firewalls, they will come with admin. If the organization has not changed that password, it is very easy for the person to get access, and then they will do lateral movement. Like I said, they will, from one system they will connect to the other system. So error handling and logging, don't log inappropriate data. See, this is from the compliance perspective. So compliance like GDPR and all that stuff, what can be logged, right? You cannot log everything, then it will get to the privacy side of things. So what can be logged? So you need to take care of the privacy side of things also, and the logs also should be secured. If the log is available to somebody, that can also cause harm to your organization. So again, within data protection, we talked of encryption. See, we use HTTPS everywhere, right? Secure protocol. Disable HTTP for all those things. Then store user passwords, use a strong iterative salted hash. Salted hash is like you have a plain text password, you hash it. Salt is like adding some extra characters, right? So what will happen is only the system will know what is the salt that you are using. Okay, salt is like more like a extra characters that I'm adding, okay, to the password. So when the user types his password, his or her password, that will be hashed first. Then I will know what my salt used in the system. I will add the salt. Then I will compare with the stored hash and salted password along with the real time entered password. If that matches, then that will give access. Then securely exchange encryption keys. Encryption keys, like I said, I want to digital certification, all those stuff. How do you securely share your exchange keys? If I share it openly, then I will know what is the exchange. If that gets access to, by the third parties, they can easily, change the data. So from the data protection perspective, like I said, weak TLS configuration, transport layer security, because the data gets, transmitted to the other side through the internet. So how is it getting secured? Then use valid certificates from reputable certificate authorities. There are certain industry standard certificate authorities. Okay, so you have to get your SSL certificate only from those authorities, not from everybody else. Then disable data caching using cache. Like I mentioned, right? I talked about caching. You go to the internet cafe. The last session was not closed. I can easily use it. So how do you disable cache? How often do you disable the cache? See, for example, people will say 10 minutes is the time. Beyond that, the session will get 10 minutes. In that process, the cache also will get 10 minutes. If that is open, then that is vulnerable, right? So how do you handle all those stuff? Limit the use and storage of sensitive data. Don't get unnecessary data and then store and then try to protect it. This is one of the key requirements in GDPR also. This is limited data. You have to say why you are collecting the data from the user, how you will use the data of the end user. So these are compliance requirements. Okay, you may not want to capture all the data of the end user as well. So from configuration and operation perspective, these are some of the best practices that you need to follow. Perform code reviews. I talked about static application security testing, analyzing the code when it is idle, only the code. Dynamic application security testing, I said, when the application is deployed and then you try to give some wrong data, whether application is behaving correctly, all those stuff. So testing is again one of the design review. Hey, this is what the intended scope of the application and whether the application is designed according to the business requirements, functional requirements, security requirements. This is more like a design review, code review, security testing. Harden the infrastructure. Deploy the patches at regular intervals as it is given by the vendors. For example, you have a firewall, Cisco is the vendor, and Cisco releases a patch. They identify some vulnerabilities with one customer, probably they will release the patch and you deploy the patch. How do you deploy the patch? Is it in production? You cannot directly go into the production and deploy. You may want to do it in a staging environment or something like that. Test it. If that works fine, you plan for a change management, deploy it. So these are some of things, educate the team on security, define an incident handling plan. Like I said, if there is a problem, if one system gets a malware, then how do you identify and mitigate the risk of that getting spread to the other systems? This is from the operations perspective. The authentication itself has some list of best practices. Okay. Hardcore credentials. Develop a strong password and reset. Hey, password will expire in say 30 days, 60 days. Okay. How do you reset your password? Account lockout. More than 3 retries of wrong password. So these are from authentication perspective itself. These are some of the best practices. Store database credentials and APIs keys securely. Okay, you have a key to encrypt the end user's data. Where do you store the key? You should not store the key in the application itself, because if the application code gets hacked, then they have the key. Then they will. So what are the best practices? How do you store the keys itself is a very important thing. Applications and middleware should run with minimal. See, in the cloud environment, okay. So far we have talked about applications that we develop. In the cloud world, what happens is communication between machines. One server wants to connect to the other server, right? It goes with the user's mindset. For example, if I am the user, I am accessing a system, I give my user ID and password, right? Same way, if there is an application A, there is another application B. This application A wants to access application B to pull out some data. So how can this access? It's similar to the user ID password kind of stuff. Okay. So in that you store that user ID and password, least control, need to know all those stuff kind of in a configuration file. So application A dynamically will pull that information, share that with the application B. Application B will validate, hey, this is the application A is trying to access my system, and then it will perform. Okay, so and everything should operate with the minimal privileges. If it has application A has to pull out only relevant data, it has to. It should not be allowed to pull out everything. We talked of session management as well, right? How you terminate your session, how do you close your session properly, okay? Regenerate session tokens, timeout. So as part of session management, there is a user connecting to my system, how that user should behave, how long can they be idle, when should I terminate the session, in the next login process, okay? To ease the user login, do I still keep everything in cache? If I keep everything in cache for unlimited time, it is a problem. So session management, what are the best practices? These are all the best practices. Cookie expiration came, right? Place a logout button on every page. Most of the users, you simply close the browser button, right? But it's not going to terminate your session. So within your application, you will see, okay, if this user logged in at this time, it's more than 10 minutes, there is no activity after this, I'm going to terminate my session from the application perspective. So next time when you log in, it will ask for a user ID password. These are some of the references that you can go and see. I talked of OWASP. From the input and output handling, what does the user enter? How am I validating it? What is the kind of output that it should do? So contextual output encoding. For example, depending on where the output will end up in the HTML, the output must be there is something called encoding. HTML pages, right? How do you see that? You see a beautiful web page, right? You have various characters, ASCII characters, everything. So there is an encoding that happens before it gets rendered onto your HTML page. So how do you take care of all those things? Whitelist and blacklisting, like said, what is allowed and what is not allowed. So you have to be very careful of it. And parameterized SQL queries, you will understand as you develop your applications. You just pass parameters. For example, I want my marks. What is the minimum thing that I need to provide? My student ID, my subject ID, then I will get the marks. Okay, subject ID 1, 2, then it will give me 2 marks. Right? This is called parameters. You just pass the parameter and then it will load. Rather than hard coding. For example, if you have 100 students, you don't write 100 queries where student ID equal to 1, 2, 3. You just share it. Then based on what is the input value, it is going to render the output. So again, probably when you have time, you can just go through. These are all the best practices. Okay. So again, these are guidelines from NIST and other people as they publish it. By following this, you will have access controls. Again, we talked in depth about all those access control, right? Discretionary access control, mandatory access control, role based, rule based, attribute based, right? For example, say don't use unvalidated forwards or redirects. This is what the malicious people will try to do. There will be a link in your application which is supposed to take you to a different page, but the intent of the malicious person is to inject a script in your application code that will point to a different site. For example, you can try it out. For example, ICICI Bank, instead of I, they will put an L which will look similar to an I. So instead of an ICICI Bank, it will land up a different site which will look like an ICICI Bank. They capture your data and then probably they will use it anywhere else. So apply the principle of least privilege, because these things will help you to minimize the risk. Again, I said this is not going to eliminate the risk entirely, right? Least privilege is like, hey, I'm minimizing my damage by giving access only to this portion of it. One record losing is fine. I'm losing your entire corporate data set. It's a colossal damage, right? So these are the best practices. So again, what are the common vulnerability exposure risks? and I have given what are the safeguard measures. For example, broken access control. What is it? Right? For example, it can help hackers change user privilege settings. If the access control, like user ID, password, authentication, all those stuff, if there is a break in any of these things, that will help the access change the user privileges itself. An administrator may lose his privilege. He may not be able to log into the system because somebody else has changed their privilege. So, and what are the safeguard measures? For example, continuous penetration testing. Okay, delete accounts that are, for example, an employee quits an organization. Can you still retain their user ID, password, access to different systems? No, because they may try to access the system even after they leaving the organization, right? So these are the best practices. Okay, conduct regular penetration testing, proper session management method. Same way, cryptographic failures. How this, for example, credit card or identity theft is mostly because of cryptography. I am not encrypting my data. I am using a weak encryption algorithm. I am using a lesser size of key. This will result in problems. So how do you do that? Most of the time, turn off autocomplete on forms. For example, you type in your mobile. The first time you type, the next word automatically comes in. Right? That is through a technology called federated learning. So in the forms also, mostly, most of the websites you visit, you type your first name. Probably when you move to the last name field, it will automatically get added, right? Because of the caching and cookies and other settings. So turn off autocomplete on forms. Use data encryption, whether it is in transit, at rest, or in motion. We talked of it. So deactivate caching. This is one of the best practice, right? We said caching, disable, cookie deletion, session management. These are small things, but most organizations somewhere they fail. That's what, when you look into the breaches, most of the organizations, right, be it Sony, Verizon, these organizations get breached. How can they be? It's the same, they know the best practice. It's not that they don't know the best practice, but somewhere in the process, change management or something, they will miss out. We talked of SQL injection and all those stuff, right? So it could be through SQL, operating system, no SQL, or LDAP. LDAP is more like an access control thing. So what we talked of SAC, static application security testing, right? And in dynamic application security. Parameterized queries, we said. Don't hard code the query, use parameters so that you don't know what to pass, right? So you will minimize the risk. Use a safe API instead of an eliminator. Server-side validation and intrusion detection system. So these are best practices and guidelines. Okay. Insecure design. Okay. You have to follow a safe development life cycle. Integrate checks at every layer. We talked of defense in depth, right? So even within the application, right? If the first level of your application, user ID password, if somebody knows about the user ID password, they log into your application. But after that, can you take additional measures? Once in a while, you throw a pop-up just to confirm whether it is a genuine user. You may throw a pop-up. We talked of security misconfigurations, right? So how do you ensure what should be? So you have a segmented application architecture. Don't allow the entire application to be accessible by everybody. Okay, within the application, be it a payroll, be it finance or anything else, right? You provide only limited exposure. Hey, this is the time window that you can access the application, right? This is the location from which you can access the application. So these are the measures, which will ensure. And again, continuous monitoring, we said, right? Continue. For example, in the cloud, one of the why people go to the cloud is anytime I can launch a server, anytime. Big billion day sale, for example, right? Flipkart sale, Amazon sale. They may not want to buy, servers worth millions of dollars just for that one day of sale, right? So what they will do, they will go to the cloud. As the users increase, it will launch additional servers, and as the demand comes down, the service will get shut down. But in that process, you have to do continuous monitoring. Hey, yesterday, because you have in the cloud, you have cost management, budgeting, and all those stuff. So you can easily track. You have a plan in mind. You say this is my budget. All those stuff. You can track. But if you don't track, somebody launches a new service. Okay, some administrator deploys a new thing and it constantly increases the number of servers, your cost is going to go up. So continuous monitoring and security gap misconfigurations is very, very important, and it's one of the best practice. So again, most of the top 10 is again identification authentication failures. Okay, compromised passwords. Like I said, your Google password, you have not reset it in the recent time. You have not, even though there was a communication from Gmail, you forgot to change your password. It's a compromised password. So people are going to use that compromised password, anything, keys and all that stuff. So again, multi-factor authentication. Users with administration privileges should not use, like I said, admin. If I am the systems administrator or network administrator, I should change my password. Whatever the vendor provides, immediately I should change it. And session management. So again, data integrity, we talked of encryption, proper exchange, cryptographic keys, and same way, check whether your continuous integration, continuous delivery pipeline, all those stuff, every stage, every process, whether it is complete in shape, so that at least it gives you a chance to find out whether there is a gap. Logging and monitoring, we saw it multiple times. The server side request for example, this is mostly because of an application fetching a remote resource without validating. That's what I'm telling. In my application, I have a link which ideally should take me to an ICICI bank, but in that process, it is leading to different site. This is called server request forgery. So instead of a genuine URL, without validating, it goes to a different URL. Okay. So you have to log accepted and blocked network flaw, ensure URL consistency. Hey, whether this is the same URL I am supposed to have the user taken into. If it leads to a different website, how do I find it out? Okay. So now we will just have a shift to the cloud. Okay, why cloud came into picture? Every organization used to buy a server, have an administrator, network administrator, firewall, all those stuff. As AWS, Amazon was using their own infrastructure for their own purposes, but finally they felt this could be made as a service so that every organization can use it. Like I said, just for the one day, why I need to buy thousands of servers and then throw it out? Or even if I have some set of servers, the usage of the servers, right, is not constant throughout the day. Only when all the users log in, there will be peak usage of CPU, memory, and everything. Rest of the day it is idle, right? So cloud came up with certain things which provide as an advantage to every organization, right, from the cost perspective, availability perspective, and performance perspective, right? So we have set of on-premise servers. There is a need for just for 2 hours of a day when you get more users. Only for those 2 hours you connect to the cloud. During that time you launch some servers, and as time goes by you shut down the servers. So you have availability, you provide users with the best performance, you are able to manage the cost. Okay. So in the cloud, again, there are 3 major categories. One is called the infrastructure as a service. So infrastructure as a service is I am availing only the compute, or I just want only storage. I have my users, they are uploading photos, my storage is limited in the data center. So I am just availing storage as a service. I will just have the data sent to the cloud, store all the photos there. Okay, it's a storage as a service. Same way servers, I just want additional servers only for that period I avail it. This is infrastructure as a service. So platform as a service. Okay, now I want my developers to develop an application in the cloud, and I want all the tools, technologies, everything to be there, and the hardware also. Okay, then you go for a platform as a service. And the final one is called the software as a service. For example, you have CRM applications, Salesforce, right? I don't want to develop that application. I don't want to use the technologies, frameworks, hardware, everything. I want simply Office 365, right? Why will develop my application, email, all those stuff, right? I will consume it. So you go with the SaaS model. And how these models work? For example, somebody asked, right? How do I think she asked, right? So in the on-premise environment, what is the responsibility of the corporate? See, the only thing is between the cloud and the on-premise, there is a ownership level. Where does the ownership end? Where does the ownership start and where does the ownership? So in the on-premise world, the organization is responsible for everything: physical security, network security, virtualization, operating system security, database security, application security, everything, right? This is like a co-location. It is called co-location. You don't have a data center, but then say Tata Communications or Airtel, all those providers are giving environment to host your servers. So you have your servers hosted in the other place, which is called co-location. So in that, the green is the vendor has the control. The facilities control you don't have, but rest of the things you manage the servers. They give you only the environment. The third is managed services provider. So managed services provider is they provide everything. They take care of the security, all those stuff. When it comes to cloud, we talked about infrastructure as a service, platform as a service, SaaS, software as a service, right? So if you see that in the infrastructure as a service, the green one, the AWS or Google, they are responsible only for the servers, network and facilities. Rest of the things you are responsible. Okay, still you deploy the server, you deploy your storage, you configure it, everything. Platform as a service, see, it goes up till the operating system. AWS is responsible, for example, right? Because you are leveraging only the database and applications. You leverage the tools and technologies to develop, and anyway application security is with the corporate. And finally, in the software as a service, everything is owned by the provider, cloud services provider, right? Right from facilities all the way to the database. You don't use Oracle, you don't define anything. You are consuming it as a service, and you are responsible for the management of data. Data is not responsible. Data management not their responsibility. What encryption keys you use, how do you back up the system? It is your responsibility. So this is the major difference between the on-premises side of things and the cloud side of things. So we saw this anyway. Okay, typically if you talk of say application development, software development, all those stuff, right? There are some stages. You start with the design stage. Hey, this is how my system should be designed. How many users will access my system? From which regions of the world they will access the system? What duration of the day the system will be accessed? All those stuff. What are the business requirements? Everything. Once the business requirements, translate into technical requirements. Okay, how the system should be defined, what technologies we will use, what frameworks we will use, okay, whether you will use Java or which database, all the stuff. Then it goes into the development life cycle. And sometimes you may want to, like I said, the third party integration. Hey, I want to integrate with the cloud also to store my photos. Okay, AWS S3 bucket, I want to store my photos. Or I want to use Facebook library to enable Facebook login for my users. So how do I integrate with the third parties? How do I use their APIs, and what kind of a cloud services? Okay, so these are not mandatory, but design, development, testing, rollout, that is the typical cycle. But because of cloud and third parties, this is how the current software development architecture look like. Again, we briefly talked about why. Okay, cost management, performance management, availability management. That's where these were the top drivers of going with the cloud, right? Cost, easy to implement. I don't need to worry about setting up buying the server, getting budget approvals, waiting for the server to reach my location, then deploy it into the network, test. I just want a server. I have a user ID password. I said this is the server I want to, a micro or a mini or a large. What is the instance size? I select the instance size, click, at the click of a button it comes up. So ease of deployment, and it's reliable. When I say reliable, compared to our on-premises, cloud is highly reliable because they have redundancies in place. They have redundant locations that can provide the compute and scalable.